is an array. Now, I haven't taken the attendance. I will do that later. Is an array. Is a rectangular array of numbers. For the timing, we will consider real numbers. Array of numbers. So the way we do it is, so say m rows and n columns. You see now, I am now generalizing. I'm not assuming that m equal to n. So we call this an m by n, m not m times n, m by n. So, and stop that noise. Very strict. I will be very strict throughout the course. Anybody disturbing will not be allowed to stay in the class. M by n matrix. Call this a m by, so m, it's not m times n, that's how we write it. We pronounce it as m by n matrix. M rows, n columns. So you see, it's like this. So what is the best way of writing a matrix? It will be like this. So suppose it has m rows, n columns. So see how I am writing it. See how I am writing it. So the first row, so a typical element of a matrix will be written by Aij. The first index will be row, second index column. So first row, A11, A12. It is an m by n matrix, remember. So there are n columns, A13, dot, 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 A1n. First row. Second row, A21, A22, A23, dot, 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 A2n. Like this, third row, A31, A32, A33, dot, 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 A3n. Like this, it goes on. Consider the ith row. AI1, AI2, AI3, dot, dot, dot. There is an AIJ, jth column, dot, 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 AIN. And then there is a dot, 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 dot. And finally, it's I said that it has m rows. So AM1, AM2, AM3, dot, 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 AMN. This is what a matrix is. So we say that that A is of order m by n. We write m times n, but we always say of order m by n. So a typical element is Aij. So we write A, and we can write the matrix like this, see. So where is Aij occurring? Here is my Aij. So Aij, the element in ith row and jth column. A plus B is defined, is well defined if and only if, IFF means if and only if, They have the same order. If and only they have the same order. That means both are m by n. That means what I'm saying is, if you have a 4 by 3 matrix and if you have a 2 by 2 matrix, sorry, you cannot add them. But to define matrix addition, they must be of the same order. Okay, this is the first important thing. Then there are two matrices. One is the zero matrix. So everything zero. So dot 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 dot. So that is everything zero. That's the zero matrix. Then there is the identity matrix. Identity matrix is like this. Here I have to tell you something. Sorry. A square matrix. A square matrix is a matrix. Is a matrix where m is equal to n. That is, the number of rows is the same as number of columns. That is, the number of rows is equal to the number of columns. That's a square matrix. So a diagonal matrix is a square matrix. So just a minute, you keep writing.
Professor, can you go back up a little?
Oh yeah.
Okay. Yeah, thank you.
No, I haven't taken the attendance. So just want to see one thing.
Professor?
Yes.
Right at the top, when it says m by n, that says a typical element. That's typical? What does that say?
Wait, just a minute. Just a minute, wait. Just a minute.
Okay.
Right now, reply to your question. But before that, I want to check one thing. Just give me a little time, please.
Yeah, sure.
Yeah. So I will say square matrix. Just a minute. Very good. I just want to double check whatever the things I wanted to say. What is your question? A typical element. This is typical.
Thank you.
A typical element is Aij. So just a minute, there is something I want to say here. A square matrix is a matrix where m equal to n. That's right. That is perfectly correct. Okay. So a diagonal matrix is a square matrix with like this. See, like this. Here's the diagram. So square matrix. So when I say a square matrix is a matrix of where m equal to n. So we say a matrix of order n. A square matrix of order n. So here is, so this is the diagonal. Everything else is 0. This is the diagonal. So see, so this is the main diagonal. This is called the main diagonal. So the main diagonal is non-zero and everything else is 0. Identity matrix. Now I'm getting some chats here. Did the professor email the last day's notes? Everybody got my emails, right? Yes or no?
Yes, Professor, yes.
Yeah, good. Very good.
Yes.
Very good.
Professor, I did not get your email for the last notes.
Who said that? Who?
Not Shania.
But Shania Khan, now listen, this is a very important matter. I am using your emails that are available. Just a minute. Wait. I'm talking to you. That are available on CUNY first. So you really, this is a very important matter. That's why I keep asking. So you have to check that is the email address that I have of each student, every student, that appears on CUNY first. So please go and check your CUNY first email address. This is important. When I take the attendance, I will tell you, or I will announce this clearly, that if you are not getting your emails of the notes, just go and check your CUNY first email address. Otherwise, you please separately write to me and then I will send you the notes. Okay.
Thank you, Professor.
Yeah, but first, please try to fix your CUNY first email address. That is how I send the notes to everybody. I go to the CUNY first.
Okay, thank you.
I take that math 231, this section, all the names appear, and I sent the emails, not individually, to all the students. Okay, this is very important. Okay? Okay, and if you don't get it, you must let me know. That's very important. Okay, that's fine. So suppose you have two n by n matrices, two m by n matrices. M and n are not the same here. A, so I write that as Aij. B, I write that as Bij. So A plus B is the matrix Aij plus Bij. If K is a scalar, that is any real number, then K times A is Kaij. The two matrices are equal, so A is equal to B if and only if there are 2 points here. They are both of the same order. So that means if A is 4 by 3 matrix and B is 2 by 2 matrix, it makes no sense to say they are equal or not equal. So you have to be, so that's the most important thing. So if and only if they are of the same order, and their corresponding entries are equal. And and Aij is equal to Bij for all I between 1 and m and j between 1 and n. Now, when it comes to matrix multiplication, that is a little problematic. That is a little problematic. You have to, how do we do it? It's row times column, right? So, for two matrices, A and B, to be compatible for multiplication, to be compatible, that's the word, compatible for multiplication, that is, for AB to be defined, remember, be very careful, AB to be defined, there's a strong condition. Number of columns of A must be equal to number of rows of B. So it's like this. So if A is a m by n matrix and B has to be n by something, n by say R matrix, then AB is defined, the product is defined, AB is defined. And AB will be what kind of a matrix? What will be the order of the matrix? Here it is. N and N cancel out, is of order M by R. M by R. So let's take a couple of things here, very important. Let us take a 3 by 3 matrix, and because you really need to get used to this today, and then we don't have to come back to this part. This is very important, you know. So let us take a 3 by 3 matrix, say A, or say 3 by 2 matrix. Why not? 3 by 2, huh? 3 rows, A1, 2 columns, 1, 2. A21, A22, A31, A32. So A is a three rows, 3 by 2 matrix. And B, for AB to be defined, B must have the same number of columns as A. So let us consider B to be a 2 by 3 matrix. So B is 2 by 3, that means it has 2 rows. B11, B12, B13, B21, B22, B23. And now how do we define the matrix, the product? Very careful, okay? AB.
It's a 3 by 3 matrix.
It will be a 3 by 3 matrix. Very good. Yes, it will be a 3. That's what we expect. It will be a 3 by 3 matrix. But how do I write the form? It's going to be, always remember, row by column. First, for your B, fix your first column. This column is fixed. And you are playing with all the rows here. So here it is. A11, B1, 1 plus A12, B21. A21 B11 plus A22 B21. A31 B11 plus A32 B21. This is the problem with iPad. Had it been a chalkboard. Hello, what was your question? Don't distract me. I mean, that is the problem. I mean, who is this guy? Who is this guy? Suddenly. Okay, next. A11. Okay, we are done with the first column, right? I have to do this. I don't have space. This is the problem with iPad. I need large space. Okay, this is how I will do it. AB is equal to, here it is. A11 B11 plus A12 B21. A21 B11 plus A22 B21. A31 B11 plus A32 B21. Next. So I've finished the first column. Again, now come to the second column. Play with everybody there. Okay? Play with all the rows here. A11 B12 plus A12. Always remember, row by column. A12 B22. A21 B12 plus A22 B22. A31 B12 plus A32 B22. A11 and finally B13 plus A12 B23. A21 B13 plus A22 B23. And then finally A31 B13 plus A32 B2B. Oh, this is a very big problem. B32, B23. That is your 3 by 3 matrix. That's exactly what, as he said, 3 by 3 matrix. As she said, yeah. Oh. This is the idea of matrix multiplication. So you see, why don't you try some? Say A 3 4 1 6 0 5. So it is a 3 by 2 matrix. B is, say, it should be a 2 by something, right? So 1 2 3 4 5 6 7 8. Yeah. So it has to be a 2 by 2 something. 2 by something. Otherwise, it is not defined, right? 1 2 3
Let's do 2
4.
by 1. It's easier.
I'm sorry?
Let's do 2 by 1. It's easier.
If it is what is 1, it is easier.
Can we do 2 by 2 just to make it easier or smaller?
We did a lot of 2 by 2. Wait, do find AB. But you see, first there is an observation. What is A? A is 1 2 3. 3 rows, 2 columns. B is 2 rows, 4 columns. So AB is defined. And it will be what? What kind of a matrix will AB be? Come on.
It's a 3x4 matrix.
Very good, 3 by 4 matrix. But is BA defined?
I think AB is not equal to BA.
No, that is different. That is completely different issue. My question is BA defined?
No, it is not.
BA is not even defined here. You see the problem? Number of columns of B is 4. Number of rows of A is 3. No. So BA is not defined. So we won't even talk about whether they are equal. BA doesn't exist. You see? So when you say AB is not equal to BA, that actually you have to assume that both of them exist. And that happens when they are both square matrices of the same order. A is a 3x3 matrix. B is a 3x3 matrix. Okay, then AB is defined, BA is defined. Okay, can you find A times B? Do it, let's see. Remember, we are expecting a 3x4 matrix. All of you should be doing. This is very important. And this, I want to devote this whole class on this topic, and then we are about to take the spring. We are going to take the lead then. All of you have written, right? Participants 30. I want to quickly check the names. And I have, this is a very important matter, my friends. You have to take it seriously. All of you have to be on the screen. This is a very, very serious matter. If at least your name should appear, you should also appear. Otherwise, I cannot mark you present. That's a very important matter. Abu Bakr Akhtar.
Could you share your screen, Professor, please?
Huh?
Could you share your screen, please?
A little later, please. Just a minute. I want to get the names first. Abu Bakr Akhtar. Abu Bakr Akhtar. Where is Abu Bakr Akhtar? Nee. Barahona. Hugo Barahona? Okay, got it. Thank you. Caesar?
Here.
Very good. Timothy Boyce?
I'm here.
Okay, good.
Yeah.
Nathaniel Campos. Why is there an echo? Please mute yourself. Nathaniel Campos? Nathaniel Campos, I cannot see you. Amit Charan, I saw.
Here.
Yeah, good. Ricky Chen? Okay.
Here.
Got it. Victoria Cortes?
Here.
Yeah, good. Erin Desir? Erin Desir? Stephen Dorwell.
Yeah, I'm here.
Where?
I'm here.
Okay. Yeah, thank you. Anjali, I saw her. Matthew Esposito.
Yeah.
Sebastian?
Mic on.
Yes.
Who's Sebastian?
What's
Mommy
this?
Sebastian or-
No, don't speak now. I asked for Sebastian Francois. Samuel Huang? Sebastian Jean Bart? I can see him. Yeah, I got it.
Yeah.
Got it. Thank you. Arlie Evans Joseph, I know you. Mohammed Kabir?
Yeah, I'm here.
Good. Lindita Kalach.
Here.
Thank you. Shania Khan. Yes.
Here.
Good. Wasif Khan.
I'm here.
Shakila Khatun.
I'm here, Professor.
Thank you. Stanley Lee.
Here.
Simon Low.
Here.
Yun Kong Ma.
Here.
David Mejia.
Here.
Michael Meneses.
Here.
Yeah, good. Ariel Moskowitz.
Here.
Stephen Nola. Stephen Nola. James Nung. Good. Nazia Nusha.
You're right here, Professor.
Thank you. John Puli.
I'm here.
Thank you. Sean Ramlal. Sean Ramlal. Eddie Santos. Eddie Santos. Manna Sebastian.
Here.
Good. Abdul Tani.
Here.
Okay. Alex, you?
I'm here.
Okay. Anybody whose name I did not call? Anybody whose name I did not call? Good. So let us go back to what we were discussing, that is share. Okay, what is A times B? So remember, row by column, right? Row by column. 3 times 1 plus 4 times 5. 3 plus 20, 23. And it will be a 3 by 4 matrix. Then first finish the column, right? Row by column. 1 times 1 plus 6 times 5. 1 plus 30. 0 plus 24. Remember, there will be 3 rows and 4 columns. Next. So this is done. Next. And now I have to play with this column. 2, 6, this column, this column, this column. 3 times 2 plus 4 times 6. 6 plus 24, 30. 2 plus 36, 30. 0 plus 30, 30. 3 times 3, 9. Now I'm done with this. 3 times 3, 9 plus 4, 7, 28. 28 plus 9, 37. 3 plus 6, 7 is 42. 3 plus 42, 45. 0 plus 5, 7, 35. So this is done. 3 times 4, 12 plus 4 times 8, 32. 12 plus 32, 12 plus 32, 50. 4 plus 6 is 48. 4 plus 48, 52. Times 40. There you go. Let me give you some practice questions, right? You should try them. So this is the way we are going to do it. Let's take some specific examples. Very good. Say, number 1. A is a 3 by 3 matrix. 3, 1, 2, 6. No, 3 by 3 bolun. 0, 1, minus 9, 1, 2, 3. And then B is, so its number of columns of A is 3. So number of columns of B has to be 3. And another number of rows must be 3 of B, right? Why don't you take this? 5, 7, 9. So look at this. A is a 3 by 3 matrix. B is a 3 by 1 matrix. So what should be AB? What kind of a matrix AB should be? Quick.
3 by 1.
3 by 1 matrix. It should be a 3 by 1 matrix. Very good. Find AB. All of you. If all of you should be doing, this today it's a doing day. It is not going to be a very theory day. Again, we will get back to theory on Tuesday. Today is a doing day. You really have to get used to this. Otherwise, we can't proceed a step. So somebody tell me what is AB? Hello? 15 plus 7 plus 18. 15 plus 7 is 22 plus 18, 40. 0 plus 7 minus 81. 7 minus 81. 7 minus 81. So that is minus 74. 5 plus 14. That is 19 plus 27. 19 plus 27, 26, 46. See that? Okay. Two comments. A row matrix is M by a row matrix. It has only one row.
Mic on, mic off.
1 by N matrix. So it's like this. It has one row and N columns. A column matrix is a M by 1 matrix. That means it has M rows, but it has only one column. M rows, but one column. So A11, A21, M rows, M1. Let's do something interesting. I will take a row matrix like this. 1 by 3 row matrix. 3, 6, 9. And I take a column matrix. 5, 1, minus 6. Question. Are A and B compatible for multiplication? So AB will be what kind of a matrix? You see, A is a, how many rows? One row. So A is a 1 by 3 matrix. B is a 3 by 1 matrix. So yes, AB is defined. But AB turns out to be a 1 by 1 matrix. AB is simply 3 times 5, 15 plus 6, 21. 21 minus 54. 21 minus 54. 21 minus 54 minus 54 minus 21. What is it? 33, na? Yeah, minus 33. There you go. You don't have anything else. Let's check it. 15 plus 6, 21. 54 minus 21. 54 minus 21, 33. Yeah, minus 33. So it is just a 1 by 1 matrix. That means it has one row, one column. That means it has only one entry. Okay? Good. Now I will give you, ask you to practice some questions. Practice. So first, as our friend said, she said, give us a 2 by 2 matrix. Okay. Let us give us two 2 by 2 matrices. Very good. Let us go by what she said. Minus 9, 1. And B is minus 5, 3, 10, 4. So here it is very important. Both AB and BA are defined. So find AB, BA. I give you 5 minutes time, all of you. Find AB and find BA.
Professor,
Yes?
how did you get negative 33 for the 1 by 1 matrix AB?
Yeah, it is 3 times 5, 15, plus 6, 21. 6 nines are 54, no? 3 times 5, 21. 15 plus 6, 21. 21 minus 54. Oh, no. 6 nines are... Yeah. 6 nines 54. So 21 minus 54, yeah.
Okay.
Yeah, you see, this is very important. This, everybody must get used to it. So you must set your email on CUNY first, please, all of you. Very, very important. And you must also, and remember, very important, The final exam dates are also given on CUNY first. So what is AB?
50, 30, 55, negative 17.
Let's do that. Minus 10 plus 60, 50, 45 plus 10, 55. 6 plus 24, 6 plus 24, 30, minus 27 plus 4, minus 23. And BA, minus 5, yes, question? Is minus 10, minus 27, minus 37, 20 minus 36, minus 16, minus 30 plus 3, minus 27, 60 plus 4, 64. So you can clearly see, of course, that AB is not equal to BA. You can see that. Oh. All right, so that's 2 by 2. Huh? Let's go another step. Find. This it will take a little time. Take time, that's okay, because you really need to learn. And you learn only by practicing. A is 1, 2, 3, 4, 5, 6, 7, 8, 9. B is minus 1, 5, 1, 6, 2, 9, 10, 1, minus 4. Find both AB and BA. Take your time. Take 10 minutes. So you should, within 10 minutes, you should be ready. So this is now 3 by 3. Yes. All of you done with AB? What is AB?
It's 41, 12, 7.
Okay. Let's check. Wait. You check your answer. Okay, because it will be long, right? -1 plus 12 plus 30. That's a 30 plus 12, 42 minus 1, 41. Please check your answers with me, whether I am making any mistakes. Let's see, -4 plus 30 plus 60. 60 plus 30 is 90 minus 4. 8, 6, 48, 9 times 10, 90. 90 plus 48, 138 minus 7. All of you got this first column? Good. Let's go to the second column. Okay. This times that. No? Okay. 5 plus 4, 9 plus 3, 12. 20 plus 10, 30. Plus 6, 36. 35 plus 16. 35 plus 16 is 51. Plus 9, 60. 3 plus 18, 21 minus 12. 21 minus 12. 4 plus 45. 45 plus 4 is 49. 49 minus 24. 49 minus 24 is 25. 7 plus 72. 7 plus 8 is 72. 7 plus 72, 79. 79 minus 36. Come on, tell me. 79 minus 36? 79 minus 36. 43. Is this the answer?
Yeah, that's correct.
Good, very good. Now what is BA? Tell me what is BA. -1, 5, 1, 6, 2, 9, 10, 1, minus 4 times 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is -1, 20 plus 7. 20 plus 7, 27 minus 1, 26. 6 plus 2 was 8. 6 plus 8, 14 plus 14 plus 9, 7, 63. 63 plus 14, 77. 10 plus 4, 14 minus 28 minus 14. Minus 2 plus 25. 25 minus 2 is 23 plus 8, 31. Yeah. 12 plus 10, 22. 22 plus 72. 22 plus 72, 94. 20 plus 5, 25. 25 minus 32, minus 7. 25 minus 32, yeah, minus 7. Minus 3 plus 30. 30 minus 3, 27 plus 9, 36. 18 plus 12, 30. 30 plus 81. 30 plus 81, come on. 1, 1, 1. 30 plus 6, 36. 36 minus 36, 0. Did all of you get this? And you can clearly see that AB is not equal to B.
Professor,
Yes, sir?
I'm sorry. The AB, the first row, isn't it 41, 12, 7?
No. Let's check.
Professor, I got the same answer as him. I got 7.
You got 7? Let's check.
me too.
Oh, really? Then let's check. Maybe he's right. This times that. -1 plus 12. 12 minus 1. Oh, no, you're talking about this one, right? You're talking about this guy, right?
AB.
This one, right?
Yeah, AB
Yeah, the
30.
first row.
Okay, wait. Yeah, mute yourself unless you are asking me a question. 7 plus 72, 8, 9, 72. 7 plus 72, 79. 79, what? Wait a second. I'm getting confused. Wait, this times that. 12 plus 30. Yeah, this is right, 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 this is right. He's talking about this one. This, okay, that is this one. Okay, just a minute. Okay, let's see. Okay, let's see. 1 plus 18, 19. Oh, yeah, this is 7. Thank you. Very good. Can all of you check the entries? All of you. Let me see. Early events, Joseph, I will ask you, is AB correct? Yes?
Yes, AB is correct.
Very good. Okay, now let me ask, uh, I can see Amit. Tell me, is BA correct?
Yes, that's exactly what I have.
Oh, very good. That's exactly what you have. Wonderful. Very good. Thank you. So obviously AB is not equal to BA. Okay, as I promised, let us take 5 minutes break. So when does this class end? 3:30. Let's take 10 minutes break and then, oh, no, 2:39. So let us start 2:40 now. Let us start at 2:50. We will again start at 2:50 p.m. Don't, better not to leave. You can just take a glass of water and Oh, sorry. Okay, let us come back. Now I want to explain some of you must have seen this. This is called the sigma notation. So we start with an m by n matrix. A is an m by n matrix. It's an m by n matrix. B is an n by p matrix. So therefore, the matrices A and B are compatible for multiplication. That is, A times B is well defined because the number of columns of A is equal to the number of rows of B. And therefore, AB is an M by P matrix. So let us call AB equal to the matrix C. So we know that C is a M by P matrix. So we write the matrix C as its typical element is Cij. So Cij is the element of the matrix C. Cij is the element in the ith row, jth column. And it is a M by P matrix. So I goes from 1 to M, J goes from 1 to P. Okay, now suppose you're multiplying. So you're multiplying them. So what is C11? C11 is C11. So your C will be it's a M by P matrix, no? So it's C11 C12 dot C1P. C21, C22, C22, C2P. Okay, now see what I'm going to teach you something. This is once for all we get this fixed, then we don't have to worry about this. And so it goes on like this, say, so let us come to the,
Mic off.
so dot CI1, CI2 dot CIP, and then dot there are M rows, so CM1, CM2 dot CMP. There is a little guy here. Okay, I'll talk about that later. Okay. Cij. This guy here. Cij. Typical element Cij. Okay. Okay, this is my matrix C. So what is C11? Well, let us see how we get C11. That means we fix the first column of B. Hello? We fix the first column of B. First column of B is fixed. This guy is fixed. And then we multiply and we take the first row of A. First row of A, first column of B. Correct? Correct? How do I get, so what is it? So that's what I just did over here. A11, B11, A22, A12, B21 plus A13, A13, B31, plus A1 and BN1. Stop. Can you notice one thing? Look at my pen. This you can see on the screen. This guy, this one, and this one are the same. 1, 1, 1, 1, 1, 1. 1, 1. They're all same. They're fixed. Yeah, so that's fixed. The thing is this guy. So how many indices are there? The second index of 1 and the first index of B. Second index of 2, first index of B. Second index of 3, first index of B. Second index of N, first index of B. They are changing. They're changing from I to N. That is what. This is my C11. It's a sigma summation. A1I, BI1. I goes from 1 to N. Correct? Suppose I say, what is C21? C21. How will you get C21?
That would be A21B11 plus
So very good. So C21 means, where am I? C21 means I will take the first, I will take the second row of A, first column of B. Yes or no? And that's exactly what
yes.
she was telling us that. Exactly, she was telling us. This is the problem. This is the big problem. Okay, let's write C21 here. C21. Second row, first column. A21 B11 plus A22 B12 plus dot A2NB N1. So that is sigma. No, wait. No, wait. A21.
Isn't it A22B21 instead of B12?
Absolutely. This one was correct. This one was wrong. That's why I was very good. This one, first row. B21, BN1. Yes. And now, so how will I write this as a sigma notation? Who will tell me? This 2 and 1, 2 and 1, 2 and 1 are. So, sigma A2I B I1 I runs from 1 to n. Okay? So, let us come back here. Let us come back here. I have to write A again. I'm very sorry. This is the problem of iPad. I hate this. I really don't know when we are going back to the classroom. It is so tiring to teach like this. A11, A12. I'm going to do, my attention is CIJ. I want to show you something. I go to the ith, okay. AI. No. A1J this is M by no, what did they say? A1N. Now I'm taking too much space here. That's the problem. No, that's okay. I cannot take so much space. 1N. A21, A22, A2N. It is N, yeah. Dot. AM1, AM2, AMN, and B was similarly, it is N by P, so it is M by m rows and columns. This is n by p. So b11, b12, b1p, b21, b22, b2p, and and bn1, bn2, bnp. Okay, and I'm taking AB. Now we know about AB. So I did C11. Why don't we do? So I just want to see whether you are getting the right idea here. We did C11. We did C21. How do we do C22? Or no, let's make it C32. What is C32? How will I do C32? Somebody tell me. Shania or Anjali? Come on, you all are getting it slowly. So how will
Okay.
I get my C32?
It's the summation from I
No,
equals starting
I
at 1.
don't need that. How will I write it? How will I start? Which row of A and which column of B? How will I write C32? Come on. Which row of A and which column of B?
Third row of A and second column of B.
Very good. Third row of A. So, and second column of B. Very good. A31, B12 plus third row of A. Remember, A32, B22 plus third row. But third row. A33, B23 plus dot plus third row, no? A3n and Bn2. Now you can talk about sigma. Sigma, something is wrong. Something is wrong. Third row of A. So A31, A32, A33. No. What is this? Oh. This was the problem. B12. I'm taking the second row of B, isn't it? Hello, second row of B. What is the second column of B? Sorry. Second column of B. Second column of B, that is this one. B12, B22, B32. B32. Everything fine. Everything fine. Very nice. You see, so it should be A3. Good. I. Or you may not have to write I, right? K. B, K. 3. Something's bothering me.
Professor, what is that R symbol? A3R?
There's no R. A3K. Just a minute. Something is bothering me. Third row. Let me write down the third row. Let me write down the third row. A31, A32, A3N. B1 to B21, B2, B31, B32, B32, ... Okay, now let's see. A31, B12, A32, B22, plus A33 B32. Yes.
Isn't it supposed to be A3K and BK2?
Just a minute. Oh, when you're talking about summation, okay.
Yes.
A3K BK2, K runs from 1 to 3. No. 1, 2, 3, that end. Very good. Right. Perfect. Okay. Okay. Now this is my final question. What is Cij? So it should be the ith row of A times the jth column of B. So take the ith row of A, AI1, jth column of B, B,
A1J.
huh? No, don't give me the sigma. I'm not interested in sigma now. Oh, okay. If you are that smart, that is so happy. I'm so happy to see that you noted this. Very good. Sigma A I K B K J, K goes from 1 to N. That's the formula with which I'm very happy that you noticed that. Very, very good. Good class. So that implies that's the formula, and that tells us that with this we can read all the entries of the product. This is what I wanted to really show you, and this is very easy, extremely easy. Cij, the element Cij in the matrix C, in the matrix AB, is sigma Aik Bkj, K goes from 1 to N. And why is this N coming? Because here is the, see, this is the trick. These two N's. Got it? This is product of matrices. We have done a solid, thorough work. Okay. I will jump to determinants on Tuesday because I have a big thing to show you. Tuesday's work will be a little proof-oriented, but I'm going to talk and tell you how to find the inverse of a 3x3 matrix. But before that, let's not run so fast. I need to tell you about. Let us go back to this time. I will have. Yeah, good. So let us again take the trace of a matrix. So trace of A, the A is there, is still there. Trace is the sum of the diagonal elements. Sum of diagonal elements. So trace of A is A11 plus A22 plus plus A M N. Trace of B is B11 plus B22. Yeah. B22 plus B NP.
Professor,
Mm-hmm.
what does the first trace say?
Trace is sum. Are
Thank
you
you.
asking me about this?
Yeah.
Sum of the diagonal elements. Okay, now let us consider A to be an M by N matrix and B to be an M by N matrix, because otherwise I will not be able to add them. They have, remember right at the beginning I said for two matrices to be compatible for addition, they must be of the same order. So A is A11, A1n, A21. No, I don't need that. By now, all of you are getting it nice. AM1, AMN. B is same thing, B11 and BM, yeah, M1, BMN. So trace of A is A11 plus A22 plus, no, A11, A22. Oh, yeah, sorry. So this is so sorry. This no. I don't want this. I don't want this. I don't want this. I don't want this. Sorry. You don't want it because there's a problem when you take the, because how will I talk about diagonal? Let me explain something. This is very easy. This is very easy. Let me explain something. Let me give you the motivation nicely. Let me give you the motivation next. You see, suppose I take a 3x4 matrix, 3 rows, 4 columns. How will I write the diagonal? There is no diagonal here. So the word diagonal is meaningful only when you have a square matrix. So henceforth, for the rest of this class, let A be a n by n square matrix. If A is of this form, we call it a diagonal matrix D. And if A is then A is the identity matrix of order n. And for any square matrix, A of order n, we have this property A times I is equal to I times A is equal to A. I, you can write in n by n. Oh, and now I'm telling you, so now finally we have time, let A be a n by n square matrix. So that's easy. So A11, A12, dot, 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 A1N, A21, A22, A2N, dot, 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 AN1, AN2, dot, dot, ANN. So this is the leading diagonal. So the trace of A, now I will write, trace of A is equal to the sum of the diagonal elements. Sum of the elements in the main diagonal. This is the main diagonal. So that is A11 plus A22 plus dot 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 plus ANN. So that is sigma AII, I goes from 1 to n. So if A is a square matrix Aij, I is from 1 to n, j is from 1 to n, and B is also a square matrix of the same order. Of course, they are compatible for addition. Of course, they are compatible for addition. Then A plus B is the matrix C, call it Cij, where it's very easy to write the elements Cij. Cij is simply Aij plus Bij. And that tells us something, that the trace of A plus B is equal to trace of A plus trace of B. And if K is a scalar, K is any scalar, then Ka is Kaij. That means trace of Ka is K times trace of A. Just a minute. Any other? Just want to see quickly. Anything else do I need to tell you about trace? Just a minute, please. Yeah. Yeah, if A and B are n by n matrices, trace of A plus B, okay. All right. So, finally, A is suppose a square matrix, n by n square matrix, and that is A11, A12, dot, 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 A1n, A21, A22, dot, 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 A2n, dot, 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 AN1, AN2, this is N2, dot, 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 ANN. Now, what is the transpose of A? The columns become rows, na? A11, A12, A1n. A21, second row becomes second column, A22, A2n. Third row becomes the third column, A31, A32, A33, A3n, and so on and so forth. Nth row becomes nth column, AN1, AN2, ANN. Look at the diagonal elements here. Look at the diagonal elements here. Oh, that's interesting. Trace of A is equal to trace of A transpose. That is what I will end with today. Hence, the trace of A is equal to the trace of A transpose if A is n by n square matrix. Okay. What we are going to do now, not now, sorry, that is on Tuesday, is this. You saw that if A is the 2 by 2 matrix, we started with the easiest one, then what is A inverse? We saw that A inverse equal to 1 upon AD minus BC times D A minus B minus C. That's the formula for A inverse. And we have played with that. Our task now will be, so we will be talking about 3 by 3 matrices. So for that, we need to talk about determinants of 3 by 3 matrices. So Tuesday will be 3 by 3 matrices, but our goal will be to find the inverse of a 3 by 3 matrix. I will show you two methods. And in order to do that, we will introduce new topic question: minors, cofactors, adjoint. And finally, we will reach, so I think next week, 2 days, at least 1.5 lectures we will need. Final goal, Cramer's rule, very important topic. So by the way we are doing this is, I want to finish chapter 2, totally. I want to finish chapter 2 next week. And then come back to chapter 1, finish the residue of chapter 1. We will take 4 days for that. So that's a good plan. So that means 7th and 9th, chapter 2, and then 2 weeks for the remaining of chapter 1. Why 2 weeks? 3 days, 3 days, 3 lectures. Okay, there will be no homework today because we did a lot of work today. I will end. That's where we stop today. Any questions, by the way? Any questions, anybody? Because there will be homework.
I have a question.
Yes?
The test 1 is going to be on chapter 1 and 2.
Yeah. Chapters 1 and 2.
Great. Thank you.
We don't have any other exams before the October 3rd, right? Or any homework to submit?
No. There is no homework, nothing. I will give you homework on Tuesday. Okay? Any other questions? Okay, good. Very good. So I end the meeting, and I just want to talk separately to Anjali Dutt. Anybody here who is not getting, Shania Khan, you said that you are not getting the emails?
Yes, Professor. I got the first class note in my Gmail, but the second class note, I didn't get anything. Probably I'm going to have to check on my Blackboard.
Yeah, so Step 1, please check your CUNY first IDs, because that's what I'm using to send you the notes. Fix your CUNY first IDs. And if you haven't, I'm going to send the notes today. If you don't receive anything by tomorrow, email me, and then I will send you separately. Okay?
Thank you, Professor.
Okay. Yes, thank you. First step, check your yeah, goodbye. Have a wonderful Labor Day weekend, all of you. And check your CUNY first email. All of you fix it. Because that's what I'm missing, right? Okay, that's it.